This is the table saw. It can be used for ripping, cross-cutting, resawing. You can cut rabbets and dados, and you can make angled cuts as well. Let me point out some of the features on the table saw. Here we have our control box, which should be turned on. But then to actually start your blade, then you'd use this red paddle and either pull that out or push it back in. We've got two adjustment wheels, one on the front and one on the side. The adjustment wheel on the front can lower or raise the blade. And the adjustment wheel on this side can change the angle from 90 degrees to 45 degrees or anywhere in between. Over here we have our blade area. We've got our in-feed table area and our out-feed. We have our throat plate. We have our blade. We have our splitter. Over to the side here, we have an adjustable rip fence that can be moved as needed, as well as a ruler that runs along the front of the saw that can help us to measure the width of our cut. Here's some safety guidelines for the table saw. On a typical table saw, the biggest danger would be cutting off a finger on that blade. However, in my shop, I've got saw stops, which means that that blade is connected to a computer brake cartridge on the inside of the saw, and it's sensing anytime that something not wood is touching that blade. For example, if a finger or a piece of metal or anything else not wood touches that blade, then it knows that and it will stop the blade. For example, if you see this green light down here on our control box, as I touch this blade, you'll notice that it starts flashing red. So it knows that something not wood is touching that. If something not wood is touching that blade while it's spinning, then it will engage that brake. It'll pull that blade out of the way and stop that saw almost instantly, so you won't get any more than just a little nick. So that's a great safety feature. However, it does ruin that blade and also the brake cartridge on the inside, and both those would need to be replaced. So typically we try not to set off the saw stop. If you're doing your cutting correctly, you should never have any danger of touching that blade at all. But it is nice to know that you won't be visiting the emergency room. The next safety guideline is just to make sure to do all of your setups while the saw is off. Whether that's moving the rip fence, changing the saw height, changing the angle, things like that. Just do it all while the saw is turned off, and then turn it on, make your cuts as needed, and if you need to make additional cuts, turn it off as well. You also definitely want to be at the machine operating it. You don't want to walk away while the machine is still on as well. The next safety guideline to talk about is kickback. Kickback refers to any time that a board or material is thrown from the saw. The reason that can happen is because that saw blade is spinning very fast towards you. We are working against that rotation of that blade, as we do with other machines as well. However, if that material is not supported, then it can get thrown back, and it's quite dangerous. So we want to make sure that any time that there is material between the rip fence and the blade, that it is supported, that it has support down to the table, and that it has support up against the rip fence. We also want to try to stay clear of the kickback zone. So if I'm operating the table saw, I want to at least try a little bit to either stand to the right or the left of that kickback zone. If you're ever watching a friend using the table saw and you're standing to the side, make sure that you're not standing in the kickback zone as well. Because if there is kickback, that material will get thrown quite far. So just make sure to double check your setups, make sure it's set up correctly, make sure that you are operating it correctly to prevent any kickback and to prevent triggering that saw stop. Let's talk about material. I've got a couple pieces of cherry here as an example. Now, the first thing that you want to look at on your material is the edge. You want to make sure that you have a good jointed edge on the table saw. So this board has a rough edge and a rough edge. So I actually need to go joint that edge before I can use it on the table saw. This board does have two good jointed edges, and so I'm okay to use this one on the table saw. The saw blade can go from nothing up to 3 inches high. So you can cut up to nearly 3 inches thick material. As far as width goes, you can go as close to the blade as needed, and then as wide as the table will allow. Lengthwise, you can cut quite long material. If you don't have a nice outfeed table, you may have somebody on the other side helping. If you're ever on the other side helping to catch the material being cut, make sure that you don't pull. You let the operator do the work, and you're just an extension of the table. The board minimum length is about 8 inches. If you were to measure from the tip of the saw blade to the back of the splitter, it's about 8 to 10 inches. So just keep in mind that whether you're ripping or cross-cutting, that it needs to be at least that long to safely run through the table saw. If you have anything smaller than that, you're just increasing the chance for something to go wrong or something unsafe to happen. Let's talk through and give an example of each of the different cuts that you can make on the table saw. The first one, and the most common use for the table saw, is ripping. When you're ripping, you'll be using our rip fence here. You'll also need either a push stick or a push block or a platen nearby so that you can use that and keep your fingers at a safe distance. You'll bring your material over and set it up next to the blade. Right now I've got a couple of inches above my material on that blade, which is kind of unnecessarily unsafe. So I'm going to lower that blade until my blade height is just about 1/8 of an inch or just above your material. That's a safer height. Once you've got your blade height set, now we can set our rip fence. The rip fence actually is not attached to the table. It can be removed, or sometimes we'll even move the rip fence to the left side of the blade. When you're moving the rip fence, push or pull on the actual fence. Try not to make adjustments with the handle because it can break. But once your adjustment is made, you'll clamp this handle down, and now this will not move, and it'll give us a nice steady cut. The rip fence is parallel to the saw blade, which is what we want. On the right side of the rip fence, you've got a marker with a red line, which currently is just about 4 inches. If you were to take a tape measure and measure from the right side of the blade to the left side of the rip fence, it's going to be that same measurement. There's also a red line marker on the left side, which we don't use unless we have the rip fence on the left side of the blade. So the rip fence is on the right side of the blade, we use the right marker. If the rip fence is on the left side of the blade, we use the left marker. My board currently is 3 inches wide. So for this example, I'm going to move my rip fence to 2.5 inches. We always want to maintain our margin of safety, which means that we should never have our fingers or hands closer than 2 to 4 inches away from any saw blade or cutter or anything like that. Since my rip fence is set to 2.5 inches, there's not a way that I can safely run that by hand. So I'm going to use a push stick. I'll have that push stick nearby so that when I get to that bladed area, that my hand is at a safe distance. All right, so our blade height is set, our rip fence is set, and we have a push stick nearby, and we're ready to go ahead and make a cut on this. All right, so we're ready to make our rip cut here. I need to put my safety glasses on, while I'm operating the machine in the shop. And like I said, we're going to try to prevent kickback. So we want to have our material against that rip fence. We don't want to allow the material to come up or down because that could get thrown back. We also don't want to allow the material to wiggle back and forth because that's also another way to get kickback. So I like to keep my hand right up in this area. That allows me to use my thumb to push downward on the table and the side of my finger to keep it tight to the rip fence. As I move forward, my hand will get too close to that bladed area. So I'll need to carefully scoot it back. But I don't want to let go while I'm scooting back because that removes the support that we need on the board. So I'm just going to carefully slide back, still putting support on that board. Once I get to the point where the end of the board is near the table, then I'm going to switch to my push stick and use that to do the rest of the cut. But the entire time, I want to make sure I'm putting pressure to the rip fence. Keep in mind that even though we want to put pressure against the rip fence, we never want to put pressure against the blade. So whether it's on the left or the right-hand side of the blade, we don't want to put pressure on that blade. Okay, so I've got everything set up to safely make this cut. I'm going to reach down and pull this red paddle out. As I'm operating, I'm standing to the left side of the kickback zone. Keep in mind that that paddle is designed for you to be able to turn it off using your leg, but don't accidentally turn it off. If you are halfway through a cut and you accidentally turn it off, don't remove your hands, just stop what you're doing, let it spin all the way down, carefully remove your piece, and then go ahead and turn it back on and start over as if you were starting to begin with. We never want to let go or back out of a cut on the table saw. Okay, so here's our example of our rip cut. I'm going to let it spin all the way down. And I know the urge is to go ahead and clean up your material while it's spinning down, but just go ahead and wait for those few seconds for it to spin all the way down so that you can retrieve your material without worrying about hitting that blade and triggering that saw stop. If you have someone who's catching the material for you, then they can remove the material safely from their end. We just never want to clear material or reach over that saw blade or around or to the side while it's still spinning. Let it spin down all the way, or you can walk around and retrieve your material from the back. Now you'll notice that I have an offcut. That offcut is okay to stay near the blade because it's got enough room over here that nothing's going to bind it to throw it. Our board and material, you'll notice that I pushed it all the way past the blade and all the way past the splitter so that it doesn't have a chance for kickback. If that material were to be left near the blade, even while it's spinning down, if you've turned the machine off, it may still wiggle enough to get caught and thrown. So make sure that you always push your material all the way past the blade and the splitter. So that was a successful rip cut. Now my material is at its 2.5 inches, and that can be a final dimension. So ripping is a great way to get your final width for material. The next thing to show is cross-cutting. So that was an example of ripping. Ripping is when you're cutting with the grain. Cross-cutting is when we are going to cut across the grain. When we're cross-cutting on the table saw, we want to have the rip fence moved out of the way. You might use that rip fence as a measurement stop, but it's no longer supporting your material. So, cross-cutting, it needs to be supported. And so we use what's called a miter gauge. Down below, we've got a miter gauge that looks like this. You want to make sure that it's set to 0 degrees or that it's set to the angle that you desire to set it to. If you're not sure that it's at 0 degrees, one little trick is to flip it upside down, put it in one of these tracks on the table saw, and allow it to fit snugly against the front of the table saw. Tighten that down, and now you should have 0 degrees. Your miter gauge is used to support the material. So I can hold my material tight to that miter gauge and move it back and forth, and now my board is secure and supported to make my crosscut. So I can use the miter gauge and the rip fence as a measurement stop, or the miter gauge can be used on this side as well. But keep in mind that if you're using the miter gauge on the left side and the rip fence on the right side, that material is going to become loose and could get kicked back. So you may need to use a clearance block or something else to make sure that you're not going to get any kickback. Okay, so when you're cross-cutting, it's a similar setup. You're going to check your blade height, make sure that it's about 1/8 of an inch above your material. Then you've got your miter gauge. If needed, you can set your rip fence. If you just need to square the end of a board, you don't need the rip fence. You can just set it up so that you can tell it's just going to cut off a small amount of material. So let me show you an example of cross-cutting. Since the blade is off, it's okay for me to come close and see exactly where that blade's going to cut. But I'll scoot my material back as I start the saw. And I'll let it spin down. I have a very small offcut here, but now that end should be 90 degrees to this edge. If you're using a miter gauge, you can carefully cut and then back out of a cut. It's different from when you're ripping. When you're ripping, you don't back out of a cut at all. Okay, so now I've squared this end, and let's say that I need a section that is 12 inches long. So I'll come over to my rip fence, scoot that over to 12 inches. Move my miter gauge to the right-hand side of the saw, and I will allow my material to butt up against that rip fence. I'm using my miter gauge, and now I'm going to safely make my cut. Since I'm supporting my board with the miter gauge, I'm okay. And I'll wait for that blade to totally spin down before I retrieve my material. All right, so now I have my material that is exactly 12 inches long, and I've cross-cut that here. Remember from previous videos that you can also cross-cut using other machines as well, but the table saw is a great option for cross-cutting. I'm going to show one more example. If I needed to cross-cut a board that is only 6 inches long, okay, so right about there, and I set the rip fence to 6 inches, there's not enough room for me to use the miter gauge on the right side of the blade. So I've got it here on the left side of the blade. However, once the blade finishes cutting through this material, then that blade is going to be unsupported between the rip fence and the blade, which could cause kickback. So this is not a safe way to crosscut. One trick that you can do is to use any type of block, but a push stick works nicely, as what's called a clearance block. You measure the thickness of your clearance block, and you add that measurement onto the measurement that you're cutting. So instead of 6 inches, I will set this to 6 3/4. If you need, you could also clamp that clearance block into place. But what that does is that allows me to use this to get the measurement that I want. But as soon as my material passes that clearance block, now I've got enough space that that is not going to get kicked back. So this would be a safe way to make a crosscut. And now we just wait for the machine to spin down before we retrieve our material. You may think that you can do it carefully, but the best idea is just to always wait for it to spin down to remove your material. So if you need to cross-cut shorter pieces on the table saw, then you may need to use a clearance block. You can also make angled cuts using the miter gauge, or angled cuts using the saw at a different angle. I'm not going to show an example of that, but if you have any abnormal setups, feel free to call me over and double check your setup before you actually make the cut. The next example will be the rabbet and dado. Let me show you an example of cutting a rabbet and a dado. I have 3 table saws in my shop, but this one is always set up with what's called a dado blade. You'll notice that the blade looks a little different. It looks like there's multiple blades stacked up against each other. So this is for making a wider cut. When you're ripping or cross-cutting, you are cutting through the entire material and you have an offcut. When you're cutting a rabbet or a dado, you're purposefully not cutting all the way through your material. You're just cutting a portion of your material out. So that's why we can use multiple blades. Most of the safety guidelines are the same as ripping and cross-cutting, but you do want to take additional care and just be aware that there are multiple blades here, as well as there's no splitter on the back. So you need to be very careful that you have your setup done correctly and that you're supporting your material. For a rabbet cut, it is similar to ripping, and we'll bring the rip fence over. You'll notice that I have attached a scrap board against the rip fence because when you're cutting a rabbet, you purposefully want to cover up some of your blades. So don't cut into your nice rip fence. Put some sort of scrap material on the front of that it's okay to cut through. I've got the 2 boards that we just cross-cut, so I've got our 12-inch and our 6-inch boards. The first step is to adjust the blade height. When you're cutting a rabbet or a dado, that's called the depth of cut. You probably don't want to have your depth of cut more than about half of the thickness of your material. So you can either do that by eye or you can do it using a ruler. For this example, I'm just going to go by eye. So I've set that blade height so that I know it's only going to come about halfway up my material. Once that's done, I can bring my rip fence over and cover up a portion of those blades as needed. For this example, I'm just doing it by eye, but typically you would probably be using a ruler to measure your blade height and your distance from your teeth to the fence so that you know the amount that you're cutting out. Now this is ready to go. I do want to observe my margin of safety, and so I definitely want to run this using a push block. So I'll run this example of a rabbet. I make sure to push my material significantly past those blades before moving it out of the way. And what it's done now is it has cut a little corner-shaped notch, or a rabbet, into my material. Since this is 12 inches long, that's an okay cut. My 6-inch length board now is too short to run on the table saw or to run rabbets or dados with. So if I needed a rabbet or a dado set into something of this length, then I would probably need to make those cuts while it was still long enough and then cut it down afterwards. The next one would be a dado. And a dado is similar to cross-cutting, so I need my miter gauge. Using the miter gauge in one of our tracks, I can set up similar to a crosscut and run what's called a dado. So I can be on this side or this side. I can use the rip fence as needed, or I don't have to as well. Once you get where you want, then it becomes a cut similar to a crosscut. Again, I make sure to push it well past the blades before I remove anything. The dado blades usually take a moment longer to spin down since you've got that extra mass with those extra blades. But now you can see I have cut a dado into my material. Rabbet and dado cuts can be a little bit intimidating, so sometimes we will set up sleds that help us to make these cuts safely. Here's one example from a project where I have created this sled that has these guides that fit into our tracks, and then those can be used. That helps it be a little bit safer at times. So whether you're using a miter gauge, the rip fence, a sled, just be sure that your setup is correct and that you're doing it safely. So that's the table saw. I've shown you ripping, cross-cutting, and using the rabbet and dado blade as well. The table saw is one of the machines you'll use most often in the shop, so you should become comfortable using it. But please remember all of the safety guidelines so that we protect ourselves and protect the machines.